Welcome back to the hyperbolic. Okay, welcome back. Welcome back to the hyperbolic coding chamber. Okay, we are back once again. This is a chamber explicitly designed by big tech, by me, all the stakeholders to make sure that when you come out of this chamber, coding is the least you can do. Okay, it's only the least. So we are back once again, and yeah, we have a lot of comments. So actually, we're gonna jump into it. So, actually, my first thing I'm gonna say, it's just what I was gonna say is let us consider LeetCode as a vehicle for joy. Just ponder it. Let us consider LeetCode. No. Let me steal the great words from. There were some really great words from a comment we had a long time ago. I forgot the person who wrote this, but they are a legendary commenter, and we're gonna steal the words and we're gonna say. Let us consider LeetCode as a conduit for joy. Let's just consider that. And so, that being said, let's take a look at some of the comments today. We have a comment from the God King, the legendary Kolu. I just started recently, and what language is this, by the way? Bless up. It is. And then we have another comment from the legendary ADC. What is your theme on VS Code? Actually, I think it's normal. Normal theme. Yeah, I think it's just normal dark theme. So we're keeping it OG on the normal dark theme with VS Code. If you know someone who's using a VS Code theme, you're going to tap them on the shoulder. You're going to find them, tap them on the shoulder, and you're going to say, stop it, and get some help. Actually, no, VS Code themes are pretty cool. So if you find some cool ones, I'd be pretty interested to know. I've been looking for one, but the OG theme that was the best was Adam's theme, but I'm sure someone has ported it. But yeah, we have another comment from the online gamer or the onion gamer. This is a game. These are both game. I should have said this for the game dev video. All right, I won't read this comment right now just because we gotta save it for the game dev video. So if you're interested in seeing in partaking in this discussion with me and the online gamer, you should join the Discord as well as check out the game dev video. And actually, no, there's no point. I'm just gonna say, being intentional in what you do is the first step of fulfilling your purpose. So you're gonna want to take the online gamer's words here and stamp them onto your chest because this is true. What do you think determines success? Completing the goals you set out for yourself, or seeking out challenges with increasing difficulty? Bro, this is it. I would say for me, success is so impossible to define. At least for myself, being intentional is the first step. And I think this statement, being intentional in what you do, is the first step to fulfilling your purpose, is just factual. I don't have any grand answers for this, but I really feel like I'm not really certain what the answer is, but I know the answer is in being intentional. There's something about intentionality that somehow gives you like a counter direction. You kind of see them, like, I don't know how to explain it, but when I think about something, like, for example, when I say, like, we're talking about being intentional, right? Let's say I want to scroll, right? Just a dopaminergic response. I'm feeling the great anticipation from scrolling on TikTok or something, or YouTube or Hacker News or something, and I'm feeling that great want. I start scrolling, and then immediately, 30 seconds after scrolling, I'm thinking, I don't want this. And so it's like this weird thing where it's like, my choice to use Hacker News or whatever, or scrolling whatever, is like not intentional. But for some reason, when I actually choose to do something, or I choose to do something that is not something that I want to do, like it's purely like dopaminergic, there's always some sort of counter signal that is just like I'm never scrolling and saying I want to do this. It's always before I scroll, I say I want to do it. During, I never actually want to. And it's in that space where it's just like I'm needing some intentionality. So it's like by not doing what I need to be doing, my mind is just screaming at me like, bro, you should be doing something else, or you should be trying to get after something. You should be trying to like achieve something, or I'm kind of filtering out my thought process here, but yeah, I just always feel like there's just something about being monkey and our brains just wanting infinite anticipation. There's nothing at the end of it, and it's just like an empty treadmill. And I'm saying that, but I partake in the treadmill literally every day. So there's just some crazy hardwiring here that's just like such a challenge to beat, to be honest. Sometimes I'm ranting. But what do you think determines success? I think for myself, I'm not exactly certain. I know one thing for certain. I would define. I think the one thing I want to do is this is gonna sound weird, but I want to trade myself for something. I want to be like, I really tried at something. There's never been something I've done where I'm like, oh, I tried my hardest. So I feel like once I finally try my hardest, I feel like I'll be done. But I feel like all of this is just me trying to get there. So if we ever get to a point where we're programming or we're doing something or whatever it is, maybe we have multiple challenges going or something, and there's like, I'm actually pumping out like a nice 16-hour day, I would say that's success. Because I think at the end of it, I'm just bouncing around here, but yeah, I think at the end of it, I just want to know that I tried as hard as I could. And I think knowing that I tried as hard as I could will finally free me from regret. So I'm hoping, I guess maybe success is, maybe, I'm just going to throw this out there. Maybe success is being free from regret. I'm not certain. But I think for myself, I would just like to have tried as hard as I can at something. Because I feel like I just never try hard enough. I'll give up too soon, or I'll do something for a little bit and then I'll stop. I just want to see what it would be like to have actually traded a large part of myself for something. A large part of myself for something. Completing the goals you set off. But I think this is kind of circular, because I say I want to try as hard as I can, but when I try hard at something, the bar is raised. So if, let's say, I could only output like 50 pounds of force, I output 50 pounds of force. The next day I wake up, I can output 55. So now I'm like, oh, I didn't really try as hard as I could have, so I have to do 55 now, and then 60, and then 65. So yeah, I think it's kind of circular. But I love the increasing difficulty aspect of that. But yeah, these are legendary questions. I wish I had a better answer, but these are some of the great life questions to ponder upon. Some of the great life questions to ponder upon. I ache for your answer, brother. But yeah, I would just really like to have tried at something, to be honest. So yeah, I can't really put into better words, but I just would really have liked to have known that I traded myself for something. Like there was nothing else left in the tank. My mind will finally just be like, bro, there was nothing else you could have done. Like, there was just nothing else to do. You did it. You gave everything you had. The engine is literally on E, and that's it. And I think I'll just be satisfied in that. But we have a legendary comment from ADC. Just got out of a VC with Elon. True. Yeah. We had ADC on, and he was talking to Elon. According to Musk, he is currently using an Elden Ring build that focuses on dexterity and intelligence, which allows him to play as a mage, but also use melee weapons when needed. Musk says that he uses a shield in his left hand, while he typically holds a staff in his right hand. When Musk's Elden Ring character isn't casting spells, he likes to use the rapier. Is this generated by ChatGPT? He likes to use the rapier and claws. Musk is also fluid when it comes to the armor that his Elden Ring character wears, switching between heavy and medium weight depending on if he needs to roll fast or function more like a tank. True. Yeah. So it was me, ADC. We had an Elon in a VC. We had Drake join a little bit afterwards, but we were just, shooting the shop, talking about Elden Ring builds. We were considering all working on a track together, but we'll have to see. ADC's running point on the next time we do a VC, the voice chat. But yeah, these are just casual interactions within the Discord. So if you're interested in something like this, and just casual VCs with Elon, Drake, other big tech and music executives, you might as well join the Discord, because that's happening every single day in the Discord. So we want to join the Discord, and we have a comment from Ashes of Osiris, deprived or suck. True. I'm not sure what that means, but true. But that's a very funny comment. Yo, this man's comments kill me every single time. But yeah, that would be the goal. So hopefully we can achieve something cool in the future. We're only 180 days in. I'd really hope at 600 days, we have to be unstoppable. Even if it's not just LeetCode, resilience-wise, we have to be unstoppable. But I don't know. We'll see. So I hope there is something there. So, but yeah, that being the case, we have some LeetCode to do as always, unfortunately. So if you love doing LeetCode, or if you love the Discord, you should join the Discord because there's lots of LeetCode happening there. Additionally, what also might be flames is also checking out the game dev video. So we do game dev every day as well, which is actually going very well. So I'll save some stuff to talk about there. And yeah, we're just going to jump into our LeetCode. So I think we're going to do a standard hour today. And we have to remove one element to make the array strictly increasing. I think we did solve this. Thank God. So we'll move on. And we have kth missing positive number. Oh wait, I'll be right back. I forgot something. So we're back once again. We're doing kth missing positive number given an array R of positive integers sorted in strictly increasing problems. Given an array R of positive integers sorted in a strictly increasing order, and an integer k, return the kth positive integer. Return the kth positive integer. What is missing? Interesting. So we have 1, 2, 3, 4. Wait, this has to have a lot. Oh, it doesn't have a lot of dislikes. The missing, we have 1, 2, 3, 4 with k equals 2. The missing positive integers are 5, 6, 7. I guess my point is, how do you know when to stop? Something like 2, 3, 4, 7, and 11. 1 is missing, 2, 3, 4, 5 is missing, 6 is missing, 7 is here, 8, 9 is the 5th number. So maybe we could literally just count up to maybe we could just count up to the last number plus k. So we do something like 4. Actually, let me check the constraints. That length is at least 1,000. And then we have 1. So we have 4 let I is equal to 0. I is less than r dot length. We'll do r dot length minus 1 plus k I plus plus. And so all the numbers that should exist should start at 1. And then we'll let missing equals 0. And then what we'll do is we can just look through the array and we'll say if r, it's not guaranteed that the array is sorted. So in fact, we could just load it all into a set. We don't know how large. Actually, r.length actually goes up to a max of 1,000. So we could just say set is equal to new set and pass in r. If we do that, we can just say, okay, if set, right, does not have r sub I, then we'll say missing plus equal 1. And we'll say if missing equals k, right, then we'll return the missing number. And the missing number must be r sub I believe. And so if we check this out for 1, 2, 3, 4 at least, the set will have numbers 1, 2, 3, and 4 in it. We're going to go from I equals 1 all the way up to 4 plus 2, which would be 6. So you actually want to include 6 here. We'll say, okay, does the set have 1? It doesn't. So we count 1. It does have 2. It does have 3. It does have 4. Does it have 5? No. So we have 2 missing. Doesn't have 6. Does have 7. Doesn't have 8. And then and we actually want to skip this if the set doesn't have I is what we actually care about. And then what we return is not r sub I, but I itself. So it seems like this is okay. This would run in linear time. Technically this would always run in less than linear time, technically, because the number that's missing is included. A number that's missing in the array at the worst case is missing from the array entirely. If that's the case, then it would be less than linear. It would be linear time because you have to look through all the numbers in the array. So less than O of n, we'd also be taking up almost linear space as well. Could take up less space by sorting the array ahead of time. Begin up with constant space but n log n time. But that still wouldn't be less than linear time complexity. I feel like this is one of those word games though where this technically is less than linear time. But it'll be hard to know. Oh, that is actually very clever. No, wait. Are they implying that we should do a binary search for every single... That would be no better than sorting the array because we do n log n time in the worst case to find the missing number. No, that wouldn't make any sense because you can't cut out any half of the array because we aren't guaranteed all the numbers. I think there is a linear time solution where we count the start and end of boundaries that don't have missing numbers, and then from there, you should be able to. It wouldn't be linear space though. Oh, that's clever. It's easy to see how many positive numbers are missing between two array elements. If you do r sub I plus 1 minus r sub I. Oh, and it did say that the problem was already sorted in strictly increasing order. R sub I plus 1, r sub I minus 1. Difference is 1, so we're good. Difference is 1, so we're good. Difference here is 2, which means that we have two missing numbers here, 5 and 6. And 3 numbers are missing there. And then from here, it wouldn't be too bad to actually just grab. I see. Approach 1 doesn't profit from the fact that the input array is sorted, and the sorted input should ring the bell. Initialize search boundaries. Yeah, I'm not understanding how they're employing binary search for this. Number of missing positive integers before the index IDX. This does not. They're right here. The sorted input should ring. Let's try logarithmic time using the binary search. I think that's one aspect of the easies. Some of the things that I don't use frequently are withering a little bit. I haven't written a binary search in a long time. This has a lot of negative votes. You have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Long flower bed in which some of the plots are planted, some are not. However, flowers cannot be planted in adjacent plots. Given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and then integer n, return if n new flowers can be planted in the flower bed without violating the no adjacent flowers rule. It seems like we just have to take the union of the... Oh. No, that would actually be worse. Fortunately, they can't be adjacent, so it actually doesn't matter. I don't think there's like a crazy optimal... I don't think there's going to be a huge precedence on order. Maybe you literally... Or maybe there is. So you have 5 zeros and ones. And then we look at them separately. 0... If n new flowers can be planted in the flower bed without violating the no adjacent flowers rule. I'm wondering if a naive approach like just counting every other element, which is 0, will work. At the end of the day, there's no actual difference. I don't think there's... Oh. No, I think we just have to check whether or not the starting position is 0 or 1, and that's what sets it. There's only 2 patterns here. If you start with a 1 here, then you can only have at max 2 set. 2 flowers planted with the no adjacent flower rule. Except if you start with 1 at the start, then you can have more. So I think we would just have to check how many numbers are 0 following this rule. If we check this way, we see there's only 1 slot available, and we want to plant 2 here. All you have to do is check if spots available is less than or equal to n. They're not giving me many test cases, so let's add one more test case, I think, and we should be able to check. This shouldn't change the answer. Oh, it's not going to run. Let's just return true. I want to see what theirs returns. It seems like we should be able to count the spots. This problem has so many dislikes, it feels like it shouldn't be possible. We'll let I equal to flower bed, I equal to if flower bed sub 0 equals 1, then I equal to 0. I guess it depends on the first index. Whether and where we find the first one. Is it on an even index or is it on an odd index? Mod 2 equals 0, then we'd set it equal to 1, otherwise we'd set it equal to 0, which means we'd have to find first one index, set it equal to 0, and then we could say while first one index is less than flower bed dot length and first flower beds of first one index equals 0, we'll do first one index plus equal 1. So we'll stop once we find our first 0 index. Then from here, we can have I is less than flower bed I plus plus we'll say I plus equal 2 issue is if we have an odd number of elements, right, we'll start at, let's just say first one is equal to 0. We'll go from index 1 to index 2, from index 2, 0, 1, 2 to index 4, right? And let's just say it was 6, right? Go boom, boom, boom. So when it's odd, we can go up to length. When it's even, however, actually, at the end of the day, what we really just want is the open spaces. I is less than flower bed dot length, I plus equals 2. This is like the problem yesterday. There's a slight way the array changes, it adds a whole bunch of edge cases. We have 0, 2, and then 4. 0, 2, and 4. I is less than flower bed dot length. And then, yeah, it ends up being 4 cases. You can start at index 0 or index 1, but also the array can either be odd or even. So let me just test all 4 of those out, actually. So here it's odd, will be even, it will be odd, So in this case, you start at 0, you go to index 2, then index 4. We're just adding 2, right, going up until length. Here we're even, start at 1, we add 2. Right, and I think actually now that I'm realizing it, this whole thing can be mitigated if we just use a while loop. If I is less than flower bed, I plus equal 2, then we can say if flower bed sub I equals 0, then we'll say available spots plus equal 1. So if we check this one for 1001, first index is going to check. First, we have to find the first one index. The first one index actually turns out to be index 0. So 0 is less than flowerbed.length, and the first one index has to be equal to 0. So it's not, it's equal to 1. So we don't add anything, and we're automatically done. Since I is equal to first, right, based on if the first index is odd, right? If the first one index is odd, then we would start at index 0. No, if the first index is even, then we start at index 0. Ideally, if the first index, let's just say it was in the center like this, right? At most, we can have one more 1. First one we find be at 0, 1, 2. First index mod 2 would equal 0, which means the first index you would start at would be 0. Now let's say the first index is actually here instead, right? So 1 mod 2 does not equal 0, so it equal 1. So we start here. You count 1 plus 2. I think I've overcomplicated this problem. I think assumed perfect uniform zeros and ones, which is probably why they didn't include a bunch of test cases here. In fact, I think you could strip all of this out and just start where the zeros are at and just check that 2 spaces to your left and 2 spaces to your right are the space to your left and the space to your right are either out of bounds or they're equal to 0. Then you can place a 1 here. So I think we definitely so we'll let I equal to 0, I is less than flowerbed.length. If flowerbed sub I equals 0, and we're going to check the left hand index sub flower beds, oh no, we have to check, right? To the left of us, right? If it's out of bounds, that's awesome. So say if I flower bed dot length, if I minus 1 is less than flower bed dot length, or flower bed sub I minus 1 equals 0, right? So this is the left hand side. And we can just basically copy this. Now we're going to check the next. If I plus 1 is greater than or equal to flower bed dot length, or flower bed I plus 1 is equal to 0, available spots plus equal 1. So start at 1 here. Nothing we can do because it's not 0. We get to this 0 here. Right, we check behind us. I minus 1 less than flower bed length? No. Flower bed I minus 1 equal to 0? No. Go to the next 0. I minus 1 is not less than flower bed, but I minus 1 is equal to 0. I plus 1 is not greater than flower bed dot length, but it is. I plus 1 is equal to 0, so we have a spot. And this one looks promising. Oh no, is greater than or equal to n. So my output here is true. We should only have one available spot, and 1 is not greater than or equal to 2. So something is going awry here. I is equal to 0, flower bed at length. If flower bed sub I is equal to 0, to go here, I minus 1 is less than flower bed dot length. It's not. Wait, no. I meant to say that this is less than 0. So yeah, this was a pretty cool one. So we'll pretty much act like we took the spot and then we'll add a 1 there to make sure that subsequent connected available spots are treated as though subsequent connected available spots. I guess that concept doesn't exist anymore. If a spot is available, we take it, right? As if it is going to take, as it is almost as if it is going to be taken. And then, yeah, we could also swap out available spots for n here and just subtract n until it equals 0. Or check if n is less than or equal to 0. This should be linear time though. I was definitely thinking the greedy approach here. So your problem called Find the Town Judge. In a town, there are n people labeled from 1 to n. In a town, there are n people labeled from 1 to n. There are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then the town judge trusts nobody. Everybody except for the town judge trusts the town judge. There is exactly one person that satisfies properties 1 and 2. Everybody except for the town judge trusts the town judge. Exactly. The town judge. The town judge. Okay. There is exactly one person that satisfies properties 1 and 2. You are given an array trust. You are given an array trust where trust sub I. You are given an array trust where trust sub I is equal to A sub I, B sub I, representing that the person labeled A sub I trusts the person labeled B sub I, and we have n people labeled from 1 to n. Return the label of the town judge. If the town judge exists, n can be identified, or return -1 otherwise. So we have to find one person that satisfies properties 1 and 2. What are the properties 1 and 2? Is it that the town judge? I see. The town judge trusts nobody. So the only people who could be the only people who could be the town judge are the people who aren't in the trust matrix. I guess it's not really. I guess it is a matrix where the first column is the truster and the second column is a trustee. Everybody except for the town judge trusts the town judge. Right. So where the town judge trusts no one and everyone trusts the town judge. So the town judge can only be someone that is not mentioned. No. The town judge can only be the person who is in the trust matrix, but only being trusted. They're not a truster. And the trusters believe that the town judge. Everyone trusts the town judge. So I think what we could just have is a matrix. We could have a matrix of trust, right? Trust, where you have we already have something called trust. We can call it a map of person to trust level. It'll be a map of number to number, right? And this map will have a person's ID, right? And it'll be mapped to it'll increase by 1 for every person who trusts that person. Right? And then we just have to find our potential judges and then return the first one. Return the first potential judge whose trust level equals n-1. So the first thing I have to do is just find the potential judges. The potential judges trust no one, so it's basically everyone. So 1 to n, right? We can reuse the person to trust level. Actually, no. This will be for. We'll just do them both. We'll have a set of trusters, right? And this will just be a set of number. And we iterate through for const truster, right? And the trustee, right, of trust. A truster will be added. Right, as well as we'll update the value of the map, right? So we'll say const vi is equal to if person to trust level dot has, right? So if a person has a trust level, right, if the trustee has a trust level, right, we'll just person to trust level dot get trust D. Otherwise, we're just going to return 0. And I'm going to slide this over so that we can actually make some progress here. And then we'll say person to trust level dot set trustee to value plus 1. Then we'll have our potential judges, which is going to be an array of IDs. From here, we can iterate from I equals 1 I is less than n, I plus plus, and then if trusters, right? If trusters does not, if this person is not part of the truster set, right, then we'll say potential judges dot push I. From here we can say for const potential judge of potential judges, right, if person to trust level dot get potential judge is equal to n minus 1, we'll return potential judge as the judge. Otherwise, we'll return -1. So this did not work. And I think I see why. I think we have to do including n. So we have one last test case that we're not passing. I just realized if we never looked at the test case that was failing, we would become a problem, because then we'd have to figure out what tests are actually failing instead of being given the test that's failing. Maybe we should make a LeetCode hard mode that hides the tests that are failing. So it looks like n is equal to 1. Our trust is no. I guess we need a special case, right? If n equals 1 and trust dot length equals 0, return n. This looks like worst case linear time with linear space used in both the person to trust level set and the truster set. I was thinking graph could be used here too, but it looked like you could just do some set stuff. The town judge is the node that has an out degree of n minus 1. No, an in degree of n minus 1 and an out degree of 0. Or maybe not. Out degree, we have 5 nodes. All right, 3 has an out degree, has an in degree of n minus 1 and out degree of 0. So we need an in degree of n minus 1. There's no town judge here because none of these nodes have an in degree of 4. And there's also no judge here, I think. Yeah, this is a really cool problem. Yeah, that was a really cool problem. We didn't get to use any graph stuff on it, but yeah, it's just a cool problem. Find the closest number to 0. Given an integer array nums of size n, return the number with the value closest to 0. Given an integer array nums of size n, return the number with the value closest to 0. There are multiple answers. Return the number with the largest value. I think you could just sort this and then use a mat. You have to look through the whole array, so maybe you don't need to sort it. Actually, it'd be faster just to do 2 linear passes through. The first pass would create the it would find the number closest to 0. Actually, you can do it in just one pass. You could have closest to 0 equals negative infinity. Then we could just say for every number, for const num of nums, return closest to 0, and then what we'll just say is the distance a number is from 0 is 0 minus that number, right? And we can take the absolute value of that. So 0 minus negative 4 gives you a distance of 4. 0 minus 2 gives you a distance of 2. 0 minus 1 gives you a distance of 1. 0 minus 4 gives you a distance of 4. So we can say if the distance is less than the number, I guess we could just keep the number that's closest to 0 and then also calculate that number's distance from 0, but it might just be more readable to use two variables. So we'll say if distance is less than min distance is less than or equal to min distance to 0, and num is greater than max num, and we can just say min distance to 0 equals distance. And max num equals num. Number we can just return as max num. So if we try it here, num of nums, distance would be 4, 2, 1, 4, 8. Negative 4 is distance, because distance of 4 is 4 less than negative infinity. No. So for min distance to 0, we just want to make this positive infinity. So is 4 less than infinity? Yes. And is num greater than max num, which is infinity? Yes. So min distance would be 4. Max num would also be 4. We have 2. Now is 2 less than or equal to 4? Yes. And is I see. So we have one small case here. So in this case, right, 2 is greater than negative 2. But if we had, maybe actually we're fine. Because you'd have 4. And 4 would be greater than negative 4. Yeah, this is what I was worried about. The distance, and this is the problem with the test cases. They're feeding me the problems with the algorithm. I should be seeing it myself. I felt it too, but either way, the fix I think is to add one more case that starts with the most restrictive portion first. So if distance is less than or equal to min distance to 0, actually, this is really convoluted. You can just say if distance is less than or equal to min distance, then we'll update the distance. Then we'll have if num is greater than less than or equal to, my brain is like farting for some reason. If distance is equal to min distance to 0, but it can't be after we've just said it, otherwise it wouldn't make any sense. So we should calculate the distance first. Let's say if distance is equal to min distance to 0 already, then we'll update it. And then if the number is bigger than it, if distance no, something is off here. I think my brain is just fried, so we'll stop there for now.